Okay, I'm going to wrap up section 2.4 today, I hope. We're going to differentiate this function. The first thing we should probably do is try to rewrite it in a friendlier way. So we could take all that's in the denominator and move it up to the numerator and just change it to a negative power. And watch out with that variable t. It looks like a plus sign sometimes. So we have made this a little friendlier. This is in the form of something to a power. So I could try the general power rule on it. I do have a -7 here. So we will just treat that constant that's being multiplied by it just like we always treat a constant. We'll just put it down and we'll get ready to multiply by what the derivative is. So we've got -7 times. Now we're ready to do the general power rule on this. It says bring the power down, multiply by the u to the one less power, and then you're going to multiply by the derivative of the u. Now we have all of this stuff is multiplied together, so we'll just do -7 and 2 and 4 for 14 times another 2 is 28. And then this has a negative power, so we can flip it to the bottom. See how these are multiplied together? So they become one fraction together. That's a 3 down there. Okay, let's see another one. Actually, now we're going to practice simplifying derivatives. That's part of the headache with these. Taking the derivative is fairly straightforward sometimes. But the work that you have to do, the algebra that you have to do to simplify it, to make it match the back of the book, that's painful. So we're going to find the derivative of f of x equals x squared times the square root of 1 minus x squared. So I'm going to try to give you some strategies of things that we can do. The overall thing that I notice with this problem, you have to sort of evaluate it and think, what type of problem is this? Because we have lots of strategies now. So when I look at this, I think that's a product. I have x squared and I have times by this square root. So I'm going to rewrite this product in a friendlier way, just changing it to the 1/2 power. So this is the first, and this is the second. And if it's a product, we're going to have to use product rule because that's the way we find the derivatives of products, or it's one of our ways. So the product rule says the first times the derivative of the second. Okay, take a second to look at the second. It's in the form where we can use the general power rule, or you can use the chain rule. If you'd like, I'll try to use the chain rule more often. So f of x is x to the 1/2, if you like the chain rule, and g of x is the inside part, so it's 1 minus x squared. You could also just go with the general power rule. So the chain rule says it's f prime of g of x. So we're going to take the derivative of f. So it's 1/2 x, but it's not an x. X is this. It's 1 minus x squared to the minus 1/2 power. And then it's times g prime of x. So now we have to take the derivative of g. So it's times by -2x. You would have gotten the same thing if you've done the power rule. You would have said the derivative of the second is 1/2 times the u to the 1 less times u prime. So it is exactly the same thing. It's just a different way of thought. So this is first times derivative of second. So it's plus second times the derivative of the first. all of this is product rule. First, derivative of second, plus second, derivative of first. That's product rule. And I told you all tonight you could leave the answer once you've taken the derivative, but I need to be showing you how we'll simplify to meet the back of the book. So all of these things right here are all multiplied together. So we got an x squared times a half times a negative 2 times an x. So the x squared times the x is going to be an x cubed. And the half times the negative 2 is going to be a negative 1. And then I've got 1 minus x squared that I just kind of skipped over and didn't use. Plus, now we're ready to do this part. Just move that out to the front. And I wouldn't be super hurt if you did this. But what we want to notice is that these terms are exactly the same. It's just one's got a negative power. So what they would really like for us to do when we have something in the parenthesis raised to a power that's exactly the same inside the parenthesis, they would like us to factor out the lowest, the greatest one we can. So first, let's look at these coefficients. We've got an x that can come out. And I can factor out a power of 1 minus x squared. And the one that I can factor out, the most that they both have is the negative a half. Then we have to write down what's left. If you took an x out of this, you're left with negative x squared. And you took all of that out, so it's gone. Plus, you took the x out of this, so you're left with the x. And you took a negative a half out of this. So when you factor, you divide. So we're left. Okay, I sent that part wrong. Right here. When we factored this x out of this, we were left with a 2. And we had some power of this left. We factored it out, which means we divided it out. And if I did this a half, when I divide like bases, I subtract their exponents. So I'm going to do this half minus this. And I'm left with just that to the 1 power, because that's 2 halves, which is 1. So it's a little bit tricky factoring out that common factor, but we will do more. Okay, I had to clear my work at the top so that I could keep going. So this leaves us, I'm going to go ahead and kick, this piece right here to the denominator. So it leaves me with an x over 1 minus x squared to the 1/2 times negative x squared plus 2 times parenthesis 1 minus x squared. So that numerator can simplify now. I've got x times negative x squared. I can distribute the 2. And we get x times, let's see, we've got some like terms. And that is going to, well, actually, we can keep simplifying. That's negative 3x to the 3rd plus 2x all over the square root of 1 minus x squared. Okay. In hindsight, I think I will pause here. I believe that's all I'll show you. We will just have to finish up this section another day. We'll just have to look at it on Monday.